In this video, I want to explain how to calculate the employee contribution and the employer match, which will only apply to the years while the client is working. And instead of using the formulas that I had originally used, because they're somewhat complicated, I'm going to split the employee contribution into two columns. One column will be if they're what I'll just call young, 49 years old or younger, and the other column will be if they're 50 years or older. And the reason I'm splitting it that way is because the IRS has a rule that says contributions by the employee cannot exceed $18,000 in 2017 dollars unless they are age 50 or older, at which point that contribution limit rises by $6,000, so from 18,000 to 24,000. And then I'm also going to split the employer match the same way for the same reason, and I'll show you that. So I'm doing the same thing as these two columns, but I'm just going to, it's actually going to be a little more complicated in the sense there's going to be four columns instead of two, but the formulas in each of those four columns will be less complicated than the long one that I have here, although it will be essentially exactly the same thing. So first, let me just show you in my inputs tab, I have this section which lists the 401k contribution limits for 2017. So in cell D4, I have the employee limit if you're 49 years or younger of 18,000, and I've named that range contribution limit young. And then in cell D5, I have the extra 6,000 that people aged 50 or older are allowed to contribute, and I called that our contribution extra old. So now I'm going to pop over to the new project where I have split those columns in half. And so I've highlighted the columns in yellow, and actually I need to scroll over here. Okay, so if an employee is 49 years or younger and working, then they will have money in this column. If they are 50 years or older and working, they'll have money in this column. But if they're not working or dead, they won't have any money anywhere. Now I added a little post-it note, or what do they call it, a sticky note, just so, and I pasted my formula into it so I could make it larger, because I cannot make this larger right here without a whole lot of extra effort, and I just thought it would be easier to post this sticky note. So I'll talk about the formula in here. So essentially I'm having it look at cell, oh, and again, this is column F that I'm working on right now. So if they're 49 years old or younger, this is the calculation I want it to perform. And this is the formula in all the cells in the yellow section of column F. So it's looking at column E, E14 in this case, because right now this is the formula from cell F14. So if E14 is blank, then put blank. I didn't mean to actually do that. I was just pointing to it with my cursor, but it accidentally moved it. So just ignore that. So if E14 is blank, put blank. Otherwise, if E or B14, which is their age, is less than 50, then we want it to look at three different things and choose the smallest number. And I'm just going to make up some numbers and talk about it. So the first thing I want it to do is minimize. I'm using the minimize function, the min function. So it's going to look at these three things separated by the commas. So E14 times the savings rate, that is just the person's salary times their savings rate percentage. So if they've chosen to save 10% of their salary, it would take their salary times 10%. The second thing that it's looking at is the contribution limit young, which for 2017 is 18,000. And remember, that's on my inputs tab. And all I'm doing here is inflating it year by year. So in 2017 it's $18,000, but in 2018 it's going to be something more. It's going to be 18,000 times 1 plus inflation raised to the power of time. So this part right here that I've got highlighted in blue is basically just this formula. Future value equal present value times 1 plus I to the n. And I'm writing the exponent with that caret symbol. There is a future value function in Excel, but just for me, it's just as easy almost to just type the formula out like I've done right here. So my contribution limit young is 18,000 for 2017 times 1 plus the rate that I want to increase it at. That rate is inflation, but on my spreadsheet, inflation is just listed as a whole number, not a percentage. So I might have 3 stored in my inflation number, which is on my inputs tab. And I'll just pop over there to show it to you. So inflation is right here. It's I was actually in a formula edit mode. So here's my inflation number, and even though it shows a percentage sign after that, that's because I used a custom format to put that percentage sign there. If I look in the actual formula bar, it's just a whole number 3, not 0.03. And if you look here in the named range section, you can see that I named that cell inflation. So it is taking that 18,000 contribution limit young times 1 plus 3 divided by 100 just to convert that inflation number to a decimal. And then I'm raising it to the power of time. The very first year, it doesn't need to be raised to the power of anything because it's 2017. But when I copy this formula down, I do want it to raise it to the power of 1 for 2018, the power of 2 for 2019, and so on. So what I have done is my exponent is A14, and that's a relative reference. So when I copy this formula down in 2018, it will say A15. And then I've subtracted the constant of A14, which is 2017. So when I copy this down to 2018, it's going to say 2018 minus 2017 and will give me an exponent of 1, which is exactly what I want. For the current year, which is 2017, it's going to take A14, which is 2017, subtract A14, which is 2017, and give me a value of 0. So it's going to raise it to the exponent of 0 for 2017, which again is exactly what I want. So now let's just make up some numbers. And I'm going to make up some numbers that are fairly easy for me to do the math in my head. So let's say this person is younger than 50 and we want it to do the minimum of E14 times the savings rate, where E14 is their salary. So let's say their salary is 100,000 and their savings rate is 5%. So E14 times the savings rate would be 5,000. And then the next variable in the min function is the contribution limit young, which is 18,000. And then I'm multiplying it by 1 plus inflation divided by 100. I'm just going to write that as 1.03, and I'm raising that to the power of 0. So all of that would, oh, there's a word for it in math, and I can't remember what, reduce, I think. This all or solves to a value of 18,000. So I'm just going to replace all of that with 18,000. And then I also have 0, and I can't remember why I have 0. I don't actually think I need that 0 there. So it would just do that. And so basically, what this formula would return if the person was alive and generating a salary and less than the age of 50, it would do the minimum of these two numbers. Now, obviously, we would rather put 18,000 into our 401k, but we've are only said that we're willing to put what 5% of our $100,000 salary. This is just the upper limit. We cannot put more than 18,000 in 2017. We meaning the employee. The employer can, and I'll talk about that in a little bit. I actually rebooted Excel and I managed to get the formula bar to display in a larger font, so that's nice. And I checked, and I do need this 0. Basically, if E14 is blank, which it will be if the person's not working, or actually it will be if the person is dead. So if the person is dead, it's going to put a blank in this column. Otherwise, it's going to put a 0 if it doesn't meet the other requirements. And I do like for it to have blanks once the person has expired. And we need it to have zeros instead of blanks, because if we want it to do any math on this cell, if it's blank, it won't do math on it. It'll give you a value error message. So for the column G, the new column G, which is the employee contribution just if they're 50 years or older, it's essentially going to be the same thing as column F, but instead of having them be less than 50, they're going to be 50 or older. And instead of just looking at the contribution limit young, I'm going to use the contribution limit young of 18,000 plus the extra 6,000 that somebody who's 50 years or older is allowed to do. So I'm just going to go look at that formula. So again, and basically I just copied the formula from F14 into G14. And I copied it by actually clicking on the cell, highlighting the formula, Control C, and then popping over here and Control V. Not by clicking on it and dragging it. The reason I copied it that way is because I didn't use absolute references everywhere I should have, and by copying it that way it takes care of that. So now in column G, I'm looking at E14 again. If it's blank, that means they're dead, so put blank. If it's greater than or equal to 50, then we need to look at the minimum of two things, or actually three things. Their salary times the savings rate, the contribution limit young, plus the extra amount that they get to contribute because they're older than 49. And then I'm just indexing it for inflation. I'm taking this present value and multiplying by 1 plus inflation to the power of time, just like I did in column F. And again, the 0 is just to put a 0 in the cells where this formula doesn't apply, and they haven't died yet. Man, this sounds weird. So it's got zeros if they're under the age of 50. Once they hit 50, this formula comes into play. And then once they stop working, it no longer applies. Because, and the way that happens is because it looks at cell E49, which contains or column E, which contains my salary, and I've programmed the salary to be 0 if they are still alive but retired. So now let's look at the employer match. And I split my employer match It used to be a single column. I'm just looking for it. So it used to be the column G, but I've split it into two columns. It's now an employer match for a 49 or younger person and another for a 50 or older person. So, and it perhaps looks fairly complicated, but most of it is just the fact that I've got really long named ranges for my uh, cells, and then here I'm just raising something to the future value again. So the way that the employer match works, if you look at my inputs, I have this combined employee employer 401k contribution limits. The IRS or Congress has just decided that if you're 49 years and younger, the total contribution to your 401k plan per year, and that includes contributions by the employee and contributions by the employer, cannot exceed $54,000. If an employee is 50 or older, the total combined contributions by employee and employer can be an extra 6,000. So a total of $60,000. And these are 2017 dollars. So in 2018 these limits will be raised a little bit to address inflation. In 2019 they'll be raised some more unless we have deflation, which hasn't happened for a while. And I don't think if we have deflation that they lower the limits. So you'll notice that I named cell D7 or 8, D8, total contributions limit young, and D9 is total contribution limits old. And those are perhaps poor name choices, but that's what I called them. So now I'm going to pop back to the calculations tab. So if E14 is blank or 0, then put blank. Otherwise, I want it to do a minimum of two things, or three things, actually. The first is the, oh, actually, let me say one more thing. So I've got this employer match and employer cap. So I'm going to pop over to the inputs tab. I have to actually hit escape and then go to the inputs tab. So here is where I entered how much the employer was willing to contribute to the employee's 401k plan. And this 100% means for every dollar that the employee contributes, the employer contributes a matching dollar. If this said 25%, it would mean for every dollar the employee contributed, the employer would contribute a matching 25 cents. This number, some employers will say, okay, I'll match you dollar for dollar up to a cap of, let's say, $3,000 a year. And so I would put 3,000 as the cap right here. If the employer doesn't have a cap, so if you put in all 18,000 that you're allowed in 2017 and your employer doesn't have a cap and they match you dollar for dollar, then they would put in a matching 18,000. So if there's no cap, I just left this blank. So here there are three things that you want to look at, and you want it to choose the lowest of the three. And I'm actually going to just pop this back up here so I can type some things. So it's going to look at the minimum of, the first thing will be the employee's contribution, which is F14, times the employer's match divided by 100. And I'm just converting this to a percentage by when I divide by 100. So let's say my employer match is $10,000. Sorry, uh, my employee contribution is $10,000 and my employer matched me dollar for dollar. So it would take 10,000 times 100% divided by 100. So this would be 1 and multiply by that 10,000 and I'd get 10,000. The second thing it's going to look at is the employer cap. Well, let's say your employer said, you know what, I'll match you dollar for dollar up until $4,000 a year. So then I would put the employer cap would just be hardwired into the inputs tab, and I named it employer cap. And I don't remember if I showed you that, so I'm going to pop back over there. Here, this cell is called employer cap. And again, right now it's blank because in my scenario that I was testing, there was no cap. And then the third one that it's going to minimize is based on the contribution limits. Basically, in 2017 dollars, the IRS has said that if a person is 49 years or younger, the contribution by the employer and employee cannot exceed 56,000. But again, it's going to be indexed by inflation. The total contribution limits young is linked to that input cell that says 56,000. So it's going to take 56,000 and then it's going to index it by inflation. I'm not sure what's going on there. There we go. Some of this is just cut off. There we go. So it's going to just index that 56,000 by inflation. So it's going to multiply by 1 plus inflation. Dividing by 100 is just converting it to a decimal. And then it's going to raise it to the power of time. This works the same way as it did in column F. So it's going to be 56,000 times 1.03 raised to the power of 0 for the very first year, for 2017. And then I'm actually just going to write this as 56,000 because that's what it would become, because raising it to the power of 0, and I actually wrote that wrong. It should be like this. So when I raise 1.03 to the power of 0, it just becomes 1. So 56,000, and notice I have a minus F14 here. F14 is this cell right here, the employee's contribution. And the reason I have that is because the total contributions by the employer and the employee cannot exceed 56,000. So I have to subtract the employee's contribution. And so just using this number, I'd said it was $10,000. So I'm going to subtract the 10,000. So this would give us 46,000. So this formula will take the minimum of these three numbers, 10,000, the employee's contribution, or 4,000, the employer's cap, or 46,000, which is the max that the employer can contribute for 2018 because the employee contributed $10,000. And 10,000 plus 46,000 gets us to the max contribution for a 49 or younger person of 56,000 in 2017. Now these, of course, are numbers I just made up. They're not the numbers that are actually showing in cell F14. But that's my process. So the thought was, let's say an employee makes a lot of money. They make $1 million in a year, and they want to save 10% of that. Well, a million, get that to work right. A million times I'm just looking at my formula. F14 would be the employer's contribution. So a million times 10% would be 100,000. I'm just going to write it like that. And let's say the employer was matching a dollar for dollar. So if the employee put in 100,000 of their 1 million that year, the employer would put in 100,000 if they matched them dollar for dollar. And then let's say there was no employer cap, so I'm just going to make this blank. But then the IRS cap comes into play. So actually, now that I'm doing all this, I see a little mistake because this would be 100,000 and this would be minus 46,000 and it would do the minimum of those. So I need to fix that. So I need to contemplate that. Well, I'll do that later. And then for column I did the exact same thing, but instead of using just the contribution limits young, I did the contributions limits young plus that extra amount that Congress allows older people to put in. So I just added it to the contribution limits young. Now, I did again all of this in a single, well, actually in two columns. And I'm going to pop over there to show those to you again. So here's my employee contribution, this whole formula. And here's my employer match. And you can see I've got just the contribution limits young here in this part and the contribution limits old plus the contribution limits young in this part. So I'm just combining both of those columns into the single column. That does result in a more complicated formula though.